So the whole file for Woodbee contains three sections. One is the things that you use to create the operations, the milling operations. Here, the section 2 will be converting the operation from Woodbee to KUKA PRC commands if we have KUKA PRC, and then here just KUKA PRC component to see the simulation and the collisions and stuff like that, and you can export the final file from here. So I disable everything here because it will take a lot of time. Just to generate the toolpath, we only need these. To start with, you're gonna start with defining your drill here with the which I have some of them here, which you can define your diameter, total length, and effective length, and so on. And then you add your drill to this custom tool. You plug it here, and then you need a holder for the drill, which is a bunch of number defining, starting with the diameter of the holder, the first diameter, and then the first height. So it's diameter, height, and so on. That creates the geometry of the holder. You also need a mesh for your custom, for your tool. Actually, this is the already, I have here the mesh, which is hidden. Okay, that's the mesh. It has to face up with its center on the 0, 0, 0. And this is where the height of the drill starts after the total height. So that's all. So we just hide this again. Now we set the maximum RPM for our tool, and that's all. So the tool is ready. To do, and then here you can choose the geometry for the milling. You can have multiple geometry, select multiple solid B-wraps, preferably because they have to be solid, then works better. And then you can add them to this component from the utility. This is where you can create different type of operation for a planar sheet milling. Although if you get experience with Woodbee, then you can use your operation from here directly, but that's usually better because it's simplified and does everything automatically. In this you have to plug in your part, and then your tool, and then the plane of the milling. The plane of the milling, now I didn't put anything because it's XY, which is our table, because the table is XY plane. So it's okay. If you're milling on the wall, you just put the plane of the wall, and or anything else. Then you have to see which kind of milling process you want to do first. You have rough milling and fine milling. The first thing you probably want to start with is to create, so I switch off this and then I turn on the raw part. When you have the raw part, depends on your drill, then you have to just recompute this thing. I will just ignore it for now. This is to modify this operation that comes here. So I'll just do directly to the to my simulation. So I'm creating operation here and I want to simulate it. So it shows, you can already see in the viewport that this green line just goes around the geometry and comes up from here and then goes down here and then cuts again. And this one, this is because I chose to simplify the raw part, and if I don't do this, it will go, if the drill can go inside, of course, it will go and cut some also detail for you. And this is defined by also this raw part offset. It will leave only 1 millimeter from the actual part, so it doesn't go and touch the thing. So you can choose between the simplified one or the more detailed one, just like that. And the simplification, if you have some different details, like now it's skipping the 28 details, so you can consider what is the biggest, what's the smallest detail you want to have in this. It's already 28, so it's these are less than 28 probably, and this is ignoring them. So So the operation already, if you look at here, you have two operations, cutting the raw part, cutting the raw part. So these are, you can have a look, and then you can also turn on this animation thing and run it and see how it basically works. Sometimes you need to just recalculate this by moving this, that's it. This is basically the resolution of the simulation, every 100 milliseconds, and then you can see how it works. You can see the holder, the drill, and everything. There's a problem here. Let's see.
Funny. It looks like here that he drives through.
Yeah, no, that's just a viewport thing, I think.
This is just funny.
Yeah.
I have seen it here. That's right.
Yeah. So let's see if I stop and see if this goes into the material or not. So this is going here, maybe.
Seems good.
Here there's a little bit of, yeah, I'm afraid this is going. So what we can do is just to increase this gap like that. So we just leave 2 millimeter. I think it's still fine. And then this doesn't go into the material. It was okay actually from before, but yeah. So that's one operation. So it's a bit slow because I'm also recording the screen. So now it's time to, if we want to do with the what is the thickness? 5 millimeter, maybe 5 millimeter is not a good. Maybe we do the 10 millimeter, the raw part, the thicker.
The raw part.
Yeah.
Maybe I'm thinking about. I have a new 8 millimeter. So I'm not sure if you with the 10 is the diameter 10 millimeter. Yes, that's diameter. Do you get 10 millimeter between in the
here?
It's more than okay. The 10 millimeter we can do here.
You want to go inside, right?
Yeah. Maybe it's better for the fine in the end. It's better when it's not too late.
So let's say you have already numbers of the total length and everything.
For the 10 millimeter.
For the 10 millimeter, this is the 10 millimeter. I measure.
Yeah, then we do the 10 millimeter. It's okay.
Okay. So just go. Sorry. Just go from here to here, and then you want to go inside, right? So we don't want to simplify the raw part. That's not possible, I guess, unless we make it 1 millimeter. Yeah, this doesn't fit here. It's too small.
It's too small.
Yeah.
Okay. Oh, this is just only one tooth is too small.
Yeah, it's my geometry is very small. It's like.
Yeah. But why is this only 2 bits? Yeah, why?
It's like from here to here is only 10 millimeters.
Okay. Funny. So good, but you recognize the offset and said, okay, I kind of with the offset I can't go inside because of it's less than 10 millimeters. I understand. Cool. I can give you the length of the 8 millimeters.
Let's try the 8 millimeter with the same height for now, because for now it's important to see only, right? So we just reduce the offset to 0.5 millimeter. It still doesn't work. I see. I didn't connect it, sorry. So now, now it works like this. We can even do, probably you can do 1 millimeter, So it's like that, and then the question is, do we want to change anything in this operation? If we want to change, then we do we add a modifier, and then we can start manipulating some of the parameters. For example, now I would just use this. Now what happens, in this one I started I can start with the angle, or I can completely change the strategy of the milling and then go here and then use a helical, and then I can go to the depth of cut and then say I just want to do it by 2 rows. So you can see now it's calculating like that, in 2 rows. And in elevation you can see these are slightly going down. You can see that line is going up. This is a spiral, basically it goes up and down. This is, I think, better than okay, you can change the starting point also from here, or sorry, from here, I guess, or in the contour setting. In the contour setting you can change the start point, so you can just say where you want to start, maybe here, in the middle of this, and but that one ends up in there. So this is something it's not, because we are doing both in the same. We can do one thing, we can have 2 of this, because there are 2 operations coming out, and then do the other one in with a different start. But for now, I think because it's a raw cut, I think it's fine just to have it here. Okay, so now if you want to also dive into this with an angle, you just, that these things are here, then you can see that you can do this with an angle. That's important. So we basically, this yellow, this warning says that you're modifying 2 operations with 1 modifier, but that's okay for us. If it's big deal, we can copy this here and then take 1 operation from here and take another one from here. I use this
so you can combine,
then you can just put it back 2 of them. After changing, you put it here together. So now if everything is good, we're gonna do we can switch off Woodbee simulation. We don't need to see it in preview, and then we can turn on the KUKA PRC, and if there is any problem, this will be red. Luckily there is no collision by chance. Usually there is collision. I mean, if we're just lucky.
Wrong position here. Is this right?
Could be. Maybe the numbers are not right.
Normally this should be.
Yeah.
Correct.
Possible. Maybe I have to delete 1 number from here. I'm not sure.
25 as the 25, the last 25. I see it.
Yeah, but usually you have to take 2 because they're always coupled. Yeah. Okay. So that's it. I think
Cool.
now your file is saved here. Here we just call this raw part. Oh, sorry, you don't have to put a space. Raw part.
Yeah.
Okay, and then apply.
And where is it saved? You have saved
I
it
saved
anywhere.
that, somewhere. I can now. Okay, let's see. We can do a quick test and see how it works.
Yeah.
One thing I didn't explain was how to set the speed and other stuff. I just disable this again. So there was in order to create these commands, you need of course you need the operation, you need your drill. The drill is also from here, you connect it to this. You also need some settings as a general settings, which includes the feeds and the speeds. This starts with one your spindles, which is either you can define either in 1000 revolution per minute or meter per minute. This is for all the operation that you plug here. If you have operation with different speeds, if there's such a thing, then you need to copy paste this and make another one, because this is will apply on all the
and then
operations.
you have to put all together into
Exactly.
this
Yeah.
yeah.
Then this the next thing which is very important is, right now I actually put that as a full speed, because this is exactly the maximum of the tool. Then here the work fit is the speed of the milling, which goes through the material, and then you can define it in millimeter per minute or millimeter per revolution rotation. And this is the rapid feed, which moves between the parts. So in actually they're all color coded. The red is the rapid feed. The yellow is the engage and retract. And if you can see any orange, we don't have an orange right now, but there would be next and return when the operation moves from one operation to another within the material or just above the material. So typically you can set everything here. These two are in actual unit, the rest are just a percentage of the work fit. Yeah, we can do that here. This are also important for when you have a very curvy object, that you need to break those curves into arc and lines. You can also do a spline. The spline will will be exporting spline commands to the robot, which is then the loading process is different. We don't want to do that, so we just approximate with the single line, and this will create a linear and circular motion. There is no spline motion here. So even if you have a very free form object, you will not get a spline in the robot. You just get arc and line. So this is the tolerance, which has to be almost next to near the Rhino tolerance, and this is the minimum arc length or segment length, maximum segment length. So the maximum segment length would be here 94 mm, 9 centimeter, not more than that, and stuff like that. Normally this is also angle threshold, which is just 1 degree. Normally these things are they should work by default. If you have weird thing, then you can come back and change them. And another thing which we have to look is our data for the tool, which is the XYZ. This is by default as per our robot. The angles or axis. This is the same number which you can see here in the in the tool actually, but I think I deleted that component. There was a tool here. Let's just show you in the picture, which is these are these numbers, X, Y, Z, and A, B, C, which defines the location of the tool according to this flange of robot. So I put them based on what was there in the spoke cam. So that's there, and that's all. So I think we can just test now one thing.